So welcome to my MOAC 7412 lecture. This is lesson 1, configuring network load balancing. So we're going to be calling this TLB from here forward. We're going to be dealing with the exam objectives for MLB, installing and configuring and upgrading clusters, all focusing around MLB. So before we talk about MLB, we have to talk about what is fault tolerance. So availability. When a server goes down, normally that means services and resources are down too, which then translates to money being lost. If your network contains external websites or databases, for example, that could control sales and ordering inventory, that server downtime could then cost that business lots of money, thus being detrimental to that business and the business needs. If it is only an internal server, it may not allow specific users internally to perform their jobs. So it may not always affect external users, it may affect just internal users. But again, that translates to lost productivity. In either case, your company loses money through lost revenues or lost productivity. So that's why this is so big. So when designing servers and the services they are going to provide, it also includes hosting resources, we often look for a service level agreement or SLA. And this SLA specifies the level of availability for both the servers, the services, and resources and what they must maintain. For example, if we have a server design that can support the availability of 5 nines, so that means uptime is 99.9999. This is much more expensive than just one that supports the availability of just 99.0. But I mean, a great example of 99.9999, that's like 6 minutes of downtime a year, versus 99.7, that's 26 hours of downtime a year, roughly. So I mean, there's a huge difference between 99.999 and just 99%. And again, these are servers, these are resources, these are things that are going to be generating money or generating productivity from employees. So they have to be available, they have to be up and running. Fault tolerance. To make a server more fault tolerant, meaning it can recover from faults or handle faults better, you should first look at different components. So if we're looking at servers, fault tolerance could be things like disks, and that could be in the form of a RAID array. Power supplies, so that we may have 2 power supplies instead of just 1. Or even network cards, and that network card could be 2 network cards instead of just 1. Again, that way if one device fails, it has a backup. But how do we do fault tolerance when we talk about servers as a whole? Normally, we do this by cluster. And a cluster is a group of linked computers that work together as one computer. For example, when you go to google.com, Google, I'm going to assume, is actually being stored on several computers, even though we think or we may view it as only one. In reality, they probably have thousands of computers behind it acting as just one giant web server. Common uses for a cluster could be things like load balancing or failover. That way the failover would be they'd have 2 servers, one active, one passive. The passive only kicks in once the active fails, versus load balancing, and that's going to be where both servers are sharing the load between both of them at all times. So moving on, we're going to talk about how to configure LBD. So, NLB is a transparently distributes traffic across multiple servers by using a virtual IP. So that a virtual IP, as well as a shared name, allows us to mask it. That way, for example, if we go to share, Realistically, that share could be 20 different nodes that are sharing the same files, but we use that one common name to access that information, and all of those 20 nodes are going to have the same copy. Now, this is supported between multiple editions of Server 2012. It's recommended that they all be the same. To support Mlb, your system must use the following requirements. First, I'm jumping the gun. I want to get back there a little bit more of NLB before I go over the prereqs. So again, it's transparent. It distributes traffic across multiple servers by using a virtual IP address. NLB gives you a fault tolerance and maybe enhanced performance by load balancing. Normally is used by mission critical web servers, but can also be used with other types of servers, services, and resources. A cluster has 2 or more servers known as a node. Each node runs a separate copy of the desired service, resource, or application. So if we want to set up several web servers, each node would have the same copy of web server data. That way, did not matter which one that you connected to, they would all have the same information. When you create an Mlb cluster, you create a virtual address as well. As the network requests are sent to the virtual network address, the requests are distributed across the nodes in the cluster. This is going to be load balancing. So how do we make sure that the servers and services are still there? We send a heartbeat. And a heartbeat is sent normally every second. And it is essentially, are you there? If you miss 5 consecutive heartbeats, then you're dropped from the cluster. But that way, only known nodes will be part of the cluster. Only responding nodes will be part of the cluster. We have this concept called convergence. When a node is added or removed from a cluster, a process known as convergence will occur. This is going to be where all the nodes know about all other nodes, and they all have the same current configuration, and that includes building membership of nodes that map to client requests. That way, every node knows about all other nodes, and so when you add one, it updates it. When you remove one, it updates it. That way, all machines know all the information that everyone else knows about. Important note, convergence can only occur if the nodes are configured with the same port rules. We're going to talk about port rules here in a little bit. Now we can talk about Mlb prereqs. All hosts have to be on the same subnet. Within each cluster, all network adapters must be either multicast or unicast, not both, not partially one, partially the other. They must all be the same. If unicast mode is used, then the network adapter that is used to handle the client to cluster traffic must support changing its MAC address. The IP addresses assigned to the nodes must be static as well. So how do we install Mlb? To install and configure an Mlb node, you must first install Mlb. Keep in mind, this is a feature, not a role. It is used to enhance other roles, but first and foremost, it's a feature. After Mlb is installed on each machine, you then have to create the nodes and add each node to the cluster. To configure the cluster, you must configure 3 types of parameters. First, a host parameter, and that defines what each node can do in the cluster. Next is a cluster parameter, and that configures the Mlb cluster as a whole. Lastly, port rules. and this controls what port the Mlb cluster services and how requests are balanced across all servers. Here is an example of our Mlb manager. So this is where you would add our clusters. The name of the server is the cluster addresses and your basic work. So port roles. These roles specify how the Mlb directs traffic based on the port and protocol being used. These are used to configure how the requests to a specific IP address and ports are directed by the cluster manager. That way you can set it so that it responds by round robin, or it sets it specific ways. So the port role will also allow you to configure that virtual IP address, the port ranges, the protocols, and the filtering modes. So here's a great example. We can add or edit specific rules. We can do filtering based off of multi-host or single host, how we want to do the affinity, things like that. Here is our convergence. You can see that after we set a virtual address, we will see what servers and what the status of the servers are, if they're converged or not. So affinity. This is what determines how the servers are going to be balancing its specific load. You use affinity settings when you use multi-host filtering. You'll notice that if you do single host, you don't normally get this option. So filtering mode. The filtering mode specifies which hosts can respond to the requests. So we can have a multi-host, a single host, or disabled. Normally, I've seen multi-host and single host responding. More often, I see single host responding. So for multi-host filtering mode, if you choose that multi-host filtering mode, you can then configure the affinity. When you go to configure the affinity, you can choose from three options: none, single, or class C. So none, any cluster node responds to any client request, even if the client is reconnecting after an interruption. This option is suitable for stateless applications where the server that creates the servicing and then services that request doesn't have to remember the previous event to complete the request. Single is a single cluster node handles all requests from a single client. This option is used normally for stateful applications where the status of a process or transaction is maintained throughout the entire connection. Meaning, if you have to have one node start and finish the process, you want to use single. If any node can start and any node can finish, none will work. What about Class C? Class C is a single node response to all requests from a Class C network, a network within a subnet of 255.255.255.0. This is often found when you use with multi-proxy servers. This type of server is often used with cookie-based affinity or when a common database or session state server is used. So I've mainly used single. Occasionally I've used none, but most of the time I set servers to start and finish. That way if there's an interruption, a reconnection, it will actually go back to the appropriate single server that was serving it. Cluster operations mode. On the cluster parameter tab, you can configure the virtual IP or the VIP, the subnet mask DNS name that the cluster will be using. You also can configure the cluster operation mode, which specifies whether a multicast MAC address should be used for the cluster. As in contrast, Unicast mode. When you configure an Mlb cluster to use Unicast mode, Mlb replaces the network card's original MAC address and all cluster hosts with the same Unicast MAC address. When you use Unicast mode with a single NIC adapter on each node, the computer can communicate only with computers within the same subnets. As opposed to, again, multicast, when an Mlb host is in a multicast, each Mlb network adapter has two MAC addresses, the original and the virtual. The Internet Group Message Protocol, IGMP, is normally used as a special form of multicast mode that prevents the network switch from flooding with traffic. When you use a IGMP multicast mode, traffic is forwarded only through the switch port that are part of the Mlb cluster. However, to use IGMP multicast mode, you need to switch hardware that supports IGMP multicast modes. Most high-end enterprise switches should support IGMP, but that's something you just want to look into just to verify. So how do we control hosts in Mlb? To remove a node, you can perform a stop or a drain stop action. A stop action terminates all existing connections to the cluster node and stops all Mlb services. A drain stop action blocks all new connections without terminating existing ones. That way, as all the ones that are current slowly start terminating, eventually all connections will stop because it doesn't allow for new connections. To control the host, you right-click the node, click Control Host, and select the appropriate option: Start, Stop, Drain, Suspend, or Resume, depending on your needs. Lastly is upgrading a Mlb cluster. There are two ways to upgrade a Windows Server 2008 R2 Mlb cluster, and that is we can upgrade all the hosts at one time, or we can upgrade each host one at a time. Again, mix and match modes do work, but they prefer you to have all the same one. And that's actually it for this chapter. Thank you.